So hello everyone, today we are going to solve bi-weekly contest of 164, yesterday's bi-weekly contest. So talking about the first problem, we just have to find the digit that occurs least frequently in the given decimal representation. If multiple digits have the same least frequency, choose the smallest digit. We just have to apply brute force in this. For each number which is present in this decimal representation, we just have to count frequency and return the least frequency. So I have written one of the code. There can be multiple approaches, but this is the one of the approach. As you can see, I have taken map and converted the given integer n into a string num, and I am just iterating through this string and counting the frequency of the given number. And after that, I am just calculating the least frequency, and if the multiple element with the least frequency, I am just updating the answer with the least number of digit. And let's talk about the third problem. Twisted mirror path count. Given m cross n binary grid where grid ij represents 0, grid of ij is either 0 or 1. 0 represent the cell is empty and 1 represent it's a mirror. A robot start at top left corner of the grid 0 0 and want to reach at the bottom right corner, which is m-1 and n-1, and we are given a condition. If the given cell is a mirror, you have to change the direction. If you are come from right to that particular cell, you have to go down, and if you are come by taking down path, you must have to move to the right direction. If you move out of the boundary, there is an invalid path. You can't consider that path. Since the answer can be very large, we have to return modulo it 10 raised to 9 plus 7. So we are given a 2D grid, and we have to calculate the all paths. If for instance, let remove that condition of 1, that is mirror. So it is the simple question of grid paths. So we can either move right or down. We just have to calculate it by recursion. At any particular cell, either move right or either move down. So in our recursion, what we will do, if we somehow able to reach the m-1 n-1 cell, we are just returning 1. Else if we go out of bound, we are returning 0. So you can see for 0, a cell which has 0, it is the normal case, right? If the cell is 0, you calculate if you go right, how many paths possible, and if you go down, how many paths possible using recursion. And we simply calculate, we simply store in dp memoization. dp of ij is equal to right plus down, and since we have to do modulo, we are doing modulo here. I have defined a constant m with the with this value. So here we are taking 3D dp. Since we have to consider the direction if the cell is 1, so we have to case direction also. So we simply, and let me tell another thing, if we are going right, we are considering that direction as 0, and if we go down, we are considering that direction as 1. So if the cell is 1, if the cell is 1 and direction is 0, we have to go to the right cell and direction will become 1. And if the direction is 1, we have to go down. Since we have to go right, direction 0 direction 1 means you are gone via down, so you have to go right, which is I j plus 1. And if you have to go rightwards or downwards, it is I plus 1 j. This is the code for the given particular problem. I have initialized a 3D DP, as you can see, and I am just calculating it with recursion and memoization. So if we go out of bound, we will return 0. If we reach to the bottom right cell, we are returning 1. If we have previously calculated the answer of dp of I j direction, we are simply returning it. If cell is 0, we calculate the right path and down path and return it. And if not this case, so we are definitely at the cell which is consist of 1. So there can be two possible ways. Either take 0, means either the direction you came here is 0, means you came via rightward direction, so you have to go downward. So what we are going to do, go downward I plus 1 j, and now your direction is 1 since you are moving down. And in other case, you are going to right, and now your direction becomes right, and we are simply calculating modulo. So this is it. Let's submit it. So we are, for space complexity, we are storing an extra 2D vector m cross n, right? And for time complexity, we have to traverse through each and every cell, and if we have previously visited that particular cell, we certainly have cached, so the time complexity will become order of m into n, where m indicates the number of rows and n indicates number of columns. So that is it. The second and fourth problem I have skipped right now. So this is it for the bi-weekly contest 164 held on Saturday, August 30. That is it. If you want to access that particular code, you can access via my LEETCODE profile, or this particular GitHub repo. You can see my all codes. If I think it is a public repo, if I am not wrong. Yes, it is public repo. You can find the code from here. Somewhere here it will be. Yes, this is the code. You can find it from my GitHub profile. Yes, that is it for today. Thank you.